In this lesson I'd like to look at sketching derivative functions. So you can see at the top here we have the graph of the function f of x, and down here we're going to be sketching the derivative function. What you will notice is where there's an asymptote in the top, I've already drawn the asymptote in the bottom, because the derivative as you're heading towards an asymptote will also be an asymptote. So other than asymptotes, where I usually start is I look for all the places where the gradient is 0. Okay, now we know the gradient is 0 at local maxima and local minima. So here, the gradient is 0, so we know the derivative function is going to go through the x-axis here. We also know the gradient is 0 here, so it's going to go through the x-axis here. The gradient is also 0 at this point here where we've got a horizontal line. So right up to here, we know that the gradient is 0, so the line is going to go like that. At this point, however, there's a sudden change in gradient. If there's a sudden change of gradient, it's not differentiable, so we put a hollow circle. The other point where we got a sudden change in gradient, and where the gradient's almost 0, is here. So there's going to be one hollow circle here for the end of the concave up part. It also pays to identify if there are any points of inflection, and we know other points of inflection apart from stationary points, and we know that occurs where a graph's changing from concave up to concave down, for example. So we can see here, all this point of the main graph, it's concave up, and at about this point here it changes to concave down. So that means down here, and we'll change the colour to blue, somewhere down here we have a point of inflection. Now I like to work from left to right, so if we start at this point, coming up to here, we know the gradient was 0, then we had a hollow circle, but from 0 it goes to negative gradient, and quite steep negative, because we see as we go round the graph, the tangent line shows us it starts steep and negative, but it gets less and less steep until it gets to the local minimum where the gradient is 0. At this point now it's positive and it's getting steeper and steeper and steeper. So it's positive, getting steeper and steeper and steeper until it gets to the point of inflection. Now at the point of inflection it's still positive, but it's now starting to get less and less steep and head down towards a gradient of 0 at the local maximum. After the local maximum, it's now negative, and it's getting steeper and steeper and steeper as it heads towards the asymptote and infinity. So the gradient does the same as well. Now on the other side of the gradient, the other side of the asymptote, we can see it starts here, and it's still negative, it's still decreasing, and it's very steep. Okay, so that means we're here. It's negative and very steep, but it's heading towards this point here where it's almost 0. But it's actually a hollow circle now because it's a sudden change in gradient. Now after this change, we now have a constant gradient, because with a straight line the gradient's not changing, and it's negative. If it's not obvious to see what the value of the gradient is, then you can just jump to a negative number to show that you know it's a negative gradient, and then you draw it like that because we know it's constant.